All right. We're on the internet. We're on the internet. Fantastic. Okay. So let's write the mouse. I'm having hardware issues. Okay. Surprise, surprise. Oh man, that's annoying. Okay. So what do we do? So basically, I was looking around and oh no, I ran this. So we ran the command. I got back. I looked at the output of the command, and you can see that it's copying a bunch of stuff. Sometimes it found things. Sometimes it didn't find things. All in all, a rather slow process. And I'm just not confident in that approach where we were like doing the for loop and so forth. So I think what we'll do instead, right, is apparently not have a mouse wheel. What we'll do instead is, oh, and then I realized, no, this is definitely an architecture. No, it's not. It's definitely not a. I think I was getting ahead of myself there. Okay, so, all right, so let's see. So this is the for loop that I was talking about, which is less than ideal, where we do the repo query to find the file paths in there. Then what we're going to try to do instead is look for like a kind of like pip has a download option, like you can download all the packages. So DNF claims to have one of those. So we're looking to do DNF download all deps and then specify the download dir. But it's not happy with us right now. So right now it's saying no such command download. Okay, so, and you know, I think the response to this should be, let's try updating. So we'll throw the dashboard back on download. All right, so let's try upgrading DNF this time. Maybe DNF is out of date, right? And I don't know what kind of Fedora container we're in here. This would surprise me. It's probably more likely something else is weird. So DNF download, all deps downloader. Yeah, and then the next thing we're going to do is we're going to ask it to install. There's this RPM to CPIO, and then you can extract the CPIO. But there's also a Python library called RPM file, which, full disclosure, I'm sort of co-maintaining that. So we can use that as well. Because RPM to CPIO, I'm not a huge fan of it because while we're in Fedora right now, if you were to change the distro, the Python command block will largely stay the same as far as the extraction is concerned. So, because some I think Arch Linux, you don't want to try, if the RPM to CPIO, I believe, was like a stub script that didn't work on there. Not that we're going to have to run into that right now, but just as an example, lack of compatibility. So, okay, DNF install, DNF command download. Okay, so we have to install it. So I think we can. All right, let's try that. Okay, yeah, that's good. So we've got the SSI service. Right. And if we have Python installed, okay, so then once we get into Wolfie, then we can just basically add Python. Okay, no, you didn't like that. Okay. You wanted a dash Y. All right. All right, let's see. Will you download everything? Or so what we'll probably do is jump into the container, figure out the command to extract. We'll just check the layer here because it should build successfully. We'll just grab the layer here. That's the layer we want, although that was not the only package we cared about. So what's up with that? What happened to all depths? Come on. Oh, resolve. Alright, now we'll list out this directory. See what's there. Just gonna run this from the other side here as well. Alright, so that's this way. I'm just running one with the install and one without the install. Okay, so this is good. This is what we want. Holy shit, that's a lot of stuff. So I don't know if that is what we want. That's a little bit much. OpenSSL. Why is OpenSSL in there? See, that's a red flag. Lib SE Linux red flag. Okay, no thank you. So let's try kernel. Okay, here's kernel core. Kernel. Let's see if we can grab just the kernel. Oh, well, we probably want kernel modules too. Okay, maybe, you know what? Fuck that. Okay. Just give us the kernel, please. Well, we're about to find out what's in here, so it doesn't really matter. Okay, I didn't think about doing this where I set one off and then change the cache. I always like don't do this, but it's easy. You just have two shells open and you run it twice. That's a pretty good approach. So okay. Okay, kernel modules. Okay, so let's jump into this container here. Okay. So we'll just run this container here. Okay. And what do we need to do? So we want to build. Okay. Does this not work? Okay. All right. RPM2CPIL. PIL. All right, so I guess we lose on the Python front. I don't know what's happening there. It doesn't work. So RPM2CPIL, and here is exactly why. Okay, RPM2CPIO, what is the package name? It's just in the RPM package. Oh, for fuck's sake, this takes forever. Okay. Okay, so is there anything in that fucking I don't think there is. I think it's just metadata. Where's RPM file? Is there something that was info option? Right. Oh, did I forgot to release this? Oops. I think these are just failing because of the CI. Okay. Pull request. What is release? Oh, did I try to convert this? Is there an error in the YAML? Let's say there's an error in the YAML. Error in the YAML. Alright, let's try it again. release workflow. Type publish. GitHub ref. Okay. Okay, you know, I don't have time. And just throw the zip file at Pip and we'll pick it up. Oh no. Oh my gosh. Okay, so all right, so this thing so basically install. Okay, so effective. So someone contributed recently something that adds functionality. So that let's see, what is it? Info. Let's check the info. Okay. Oh, thank you. Thank you. Thank you. Size 0. Okay. So this is purely a stub. So we want kernel core probably. Let's rebuild it down here. That was cool. Hey, look at that. Let's add that to the README. Or is it already in the README? Yeah, it is. Great. Cool. Very cool. Oh, very cool. Okay. Yeah, this is a fun little module. Okay. Okay, so now that we have that, okay, so let's jump into the container. Let's jump into this container, right? And now let's see. So those archives look larger, right? So kernel core and kernel modules. So RPM file -L. Why is there no Python? Oh, because we're already in here. Okay, so we need to roll back. That's right. Okay, so we want to actually jump into this one. So this layer here, you'll see that it's right after, right? So this is the this layer build finishes, and then we do it the from Wolfie base, right? So okay. All right. Okay. Great. So now. See what's in there. Okay, look, that looks nice. That's what we want. Okay, so let's go ahead and we'll extract those. So for RPM, for file name in ls, right, do done. Okay. All right, so what do we want to do? RPM file -c build kernel. All right, so we want to change directory to there, and we want to extract file name or file path. Right. All right, so we're just looking for all of them. We're extracting them, and we're extracting them to this build kernel directory. All right. Okay. So. All right, let's check that out. Okay, so then kernel, and so then we copy from kernel to root there. So let's try that. Okay, didn't like that, so no such file directory. Okay, so we'll use let's specify the full path here. I was about to say, should we go install Whisper on here? But I think now I'm realizing I'm glad we didn't do that the other day, because it would have immediately blue screened. So, because that model's like a gig. And it seems to blue screen on anything that's like... I also noticed one time it blue screened on me when I copied to and from mount. Okay, so... all right, let's see. Ooh. Did it go? All right, let's see. Let's find out. Okay, so let's do a podman. Yeah, localhost. Okay, so let's do podman history. There's a way to make it no trunk. That's what we want. No, don't truncate. Yeah, but I think that's what it is in Docker. But we'll see what it is in Podman. Okay, great. So copy. Okay, so we got 121. Okay, so we copied from SSI server. We had a 20.6 megabyte binary that we copied, and then we got 121 megabytes from all that stuff that we grabbed from kernel core and kernel modules. So that's a lot better than the 0 we were seeing earlier. Right, so let's give it a shot. Or let's just like jump in there and see what's up. We're having a lot of little schemas now. Okay, so okay, so it doesn't have the system map stuff. Okay. 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 So is. Okay, this is the kernel. Lib modules. So let me do. So VM Linux and the reason. Okay, yeah, Linux kernel x86. Fuck yeah. All right. So we will add this. This is what we've got, right? Okay, so now let's also update. Fantastic, fantastic. Okay, great. Okay, now we're going to copy this. Oh, it's decentralized. Wonderful. All right, okay. Hey, look, we got a working image build, so that's exciting. So now we want to boot it, right? So where is good old QEMU? All right, so we have a running whatchamacallit over here. Okay, so we're gonna SSHN down here, and we are going to QEMU system or here. So we're now going to go to the blog post that we're referencing, which is basically this. And we're going to, what are we doing? Oh, we're running it. So we're going to run QEMU system x86 64. All right, so that's like also known as AMD 64. So the kernel, okay, so the BZ image, okay, so enable KVM, CPU host, okay, that's not what we want. We want to do a 9P pass-through. Where is the 9P? Fuck sticks, where's the 9P pass-through code? Okay. Let's see. Five years ago this was? Wow. This looks more like it. Okay. There we go. Okay, so we need to enable this 9P FS. We want to what? Okay, so here. This is the other part. This equation. Okay. Okay, so BZ image. Okay, so chroot equals temp slash OS decentralis. I'm just going to call it LSOS. Okay, this is somebody's learning project. What is this? Okay, so this doesn't exist. Okay. I think we can safely call it LSOS. AKA okay, I think what is this? Alice runs on Fedora. Yes, we're trying to take the Fedora kernel. Yes, this is true. What is this though? What is your Alice thing? Okay. I can't tell what this is. I can't tell if we can take this name or not because it looks like it's archived. So I think we can safely, what's this? 2018. This looks, what is this? Okay, you know, I think we'll go with decentralis. Sounds cool anyways. Decentralis. Okay, let's take a look at decentralis chroot. Okay. And then okay, and then BZ image, and then we'll point it at that. All right, so we'll point it at the C chroot. Okay. Okay. So, and where was it in there? It was here, right? So BZ image, and actually, you know, let's just go ahead and do. Right, let's just do the same thing, just to avoid any confusion if the name changes, right? Okay, which it will with the version. So BZ image or VM Linux. Okay, So this should do it for us. So init, no systemd. We have no systemd. User bin bash. Okay. I'll write this to okay. Decentralis.sh. Okay. Oh. We missed okay, we lost one of those. Okay. Could not open kernel file blank. Okay. Find. Okay. So we just need a copy in here. So basically what we're going to do is do Docker, or no, it's not Docker, it's podman run d, and then we take the image name, image. I think there's another way to do this, but okay, podman run. Okay, so container equals this, and then we do, so we take the image name. All right, so what do we want to do, right? We want to take the image we built, we want to instantiate a container, and then we want to use the copy command to copy out of it. And now why you can't just export to a flat file is beyond me. But this I think you can, but I think it involves inspecting the layers individually. I'm not sure. I know this works, so we're going to do this. That's right. I forgot. Podman is being weird. I don't like the fact that we have to run at this route, but here we are, and I don't have time. So, actually, I think this whole thing should be run as root, actually, because I think we're going to run into a similar problem with KVM. Okay, so you'll need to do cp container. Okay, and then we need to do trap exit trap podman rm podman kill. All right, so this will then on exit we'll kill the container and we'll start it with rm. So, and then here we can do build. So on the Podman CP, we're doing copy out of. We forgot to do that. So it's the container. It's kind of like a SCP syntax. So it's container instead of hostname, and then colon, and then the path. So this kernel. Okay, wait, no, actually, it's the whole thing. Actually, we just want the whole thing. So we'll just copy the root, because this is the build one. We already copied the kernel. Okay. Okay. Oh, I forgot to do. Okay, so it needs to tail dash capital F dev null. So that'll basically just keep it alive until we kill it, unless it doesn't have tail. No such container. Okay, it might not have tail, so in that case, we'll install it. Let's see what happens here. Okay, tail dash F. Alright, let's try running this without the dash D. Okay. Oh, we need to override the entry point. Is that not the long form? Whatever. Boom! We are in business! Okay. We booted. But okay, cannot open root device root. Oh, maybe we're not in business. Fuck. Fedora, are you building with 9PFS? Or is this why I always have to redo this? What about, okay. Okay, is this what's wrong? Okay, so dev root, mount tag, dev root. Let's see. I always have trouble with this. Do I have another? No. File system pass through. Okay, here's this. Five RFS type MP. RFS device 9P. RFS type MP root equals mount tag. I think there's also like a .l. We can try this. Okay, still don't like that. Okay. Okay. .l. Okay. .l, that's what I put. Excuse me. Let's see. Okay, maybe we'll do comma ro. Oh well, now this is definitely wrong. So mount tag dev root. All right, let's try that. Still don't like that. Cannot open root device root or unknown block. ID. So maybe if we add that ID, I wonder if it's not getting linked up right. Yeah. ID equals f is 0. F is dev. F is root. Okay, we'll do it like this. Right, and then root flags. Oh, share. So that's mount tags. All right, we'll try it with Hell, right? boot, 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 boot. Fuck off. Okay. Cannot open root device host share. I don't think it takes the fucking... Okay, who has... Oh, yeah, that's right. They build it as a module. They built it as a module. So let's go make an init ramfs. Okay, so... Okay, so I found this. Alright. This looks great. I really like this. So init ramfs. Okay, init ramfs. Okay, I think this is more CPIO and SCS. Okay, what's your license? Apache 2. Okay. So okay. What about that was not called config the first time? Oh, no, okay, it was at the top of the list. Okay, great. Okay, lib modules config, okay. Okay, so yeah, now we can look for 9p. Okay, so let's just look for... Just to confirm. Okay, yeah, so it's built as a module. Okay, so we need to make an init ramfs. Actually... Yeah, do we need to make an init ramfs? We probably should be making an init ramfs. Alright, let's just go look at this. Verify the boot mode. Installation, bootloader. Okay. I think that you can do systemd without nearby stub. Kernel. Okay. So in that case, dnf-y install qemu utils. There's usually like extra stuff for qemu in the network block device. Okay, oh, we already have it. Great. Okay, so let's see. So let's just go ahead. System deboot, UEFI, GPT, yes. Can be side loaded. Reports automatically detect unified kernel images. Okay, single executable. Okay, let's see if we can find alright, let's look for anything EFI related. Okay. now, okay, so preparing a unified kernel image. Okay. What is this called? Okay, what is this called now? UEFI. OVMF. That was file script or something, but no. Okay, so share OVMF. Okay, so we have this. So EDK2. Oh, look, TDX is there. Interesting. Okay, so MVF bars, MVF code, secure boot. Interesting. EDK2. Let's grab from that. Okay. Okay, BIOS. Okay, where's the bars? Okay. Okay, so we can say we just want to test that this thing runs. Okay, so you know what? I think we have a kernel in there. So we have a kernel in there. What could we do to test this? We could create a virtual machine with a hard disk, and then we could install, we could do exactly what we're going to do, and we load the, like, from a live image. So where's like the Arch Linux? Arch Linux USB. Alright, Docker. Okay. Netboot. BIOS. UEFI. Okay, so basically you can netboot. So if we supply a Pixie, running from a Pixie environment, netboot wiki page. Okay, how do we do this? Okay, here we go. Can be booted like a Linux kernel. Okay. Okay, so we want this file, basically. Okay. Okay. So we're going to take this. We're going to see about writing that in QEMU. Okay. Looks like it's booting. Bringing it up. Okay, it boots to Arch Linux. Okay. Release. Choose a mirror. Okay, let's go down to the United States. That's where we are. And let's go to good old PSU. Alright, boot Arch Linux. Oh, fuck, we're in the future. Look at this shit. This is amazing. Oh my god. Oh my god. Oh, that is beautiful. Oh my god, that's fantastic. Whoever did that deserves a medal. Okay, although now we can't see. I wonder if we can change the command line options on there. Okay. Okay, so let's give this thing a hard drive. And then let's try to install from it. So, and I believe, is one of these the EFI one? Okay. Okay, and okay, let's give this the BIOS that we wanted. From here, let's see what happens when we do this with the EDK2 code. And somebody pointed out, I believe it was the Mickey and Friends, that Eclipsium or something, local firmware company, firmware security company, that I believe the OMBF code and OMBF bars are different, and basically, like, you should, if you're running VMs as a service, you should make sure not to have these same files shared between multiple VMs because they're read-write, and so they can embed firmware exploits, or not exploits, but they can embed rootkits in there. So copy on write. Okay, so let's do that. And I'm not sure if this command buffer here, like this. Okay. Okay, so let's do. Okay, command without kernel is invalid. Or append. Let's see what happens here. UEFI. Okay, choose mirror. Okay. Oh, and I guess maybe we should have done the console thing, so maybe that would have been our clue. Maybe that's where it's supposed to go. So now, see, they already have a NARMFS, so, and because I just don't really want to deal with rolling one if, when we go to install it on this hard drive, that's not even, you know, a thing that we need to care about. So, Okay. I think we are not getting the console. So let's go ahead and create the let's go ahead and yeah, okay, so here. Okay. So alright, I think I'm gonna take a break. We're gonna create the disk basically. Or let's see, maybe we'll just do this. Actually, I think we can just copy. Okay. So, is there a trap in there? Okay. Okay, this is a basic. Okay, we probably need systemd too. We probably should be extracting systemd. Systemd network D. Yeah, okay. All right. So we need a disk. That's right. Okay, so I forgot we needed systemd. Okay, so 20 gigabytes seems good. Oh no, what is that? Okay, Z standard module not present. Okay, so we need. Okay, so I don't think we want that. Okay. Unmount image. Okay, let's just copy paste this whole thing. Okay. Okay, I think I wasn't able to successfully, when I did this a few years ago, whenever the hell this was, I was not able to figure out how to do this thing that we just did with the multi-stage correctly. So we made it farther than I got last time. Okay. Here's the image. Okay, so extract this container image to the CH root. I've been wanting to do this for a while. Obviously, it's really been killing me. I've been trying to do this for years and it hasn't worked. So I'm really hoping that this works. So because I'm just sick of not having this. Okay, so I think we can take out this init bit. We don't need that. Okay. And this is basically where we go. Okay, now CH root. Okay, so CH root. This is where we copy into the CH root now. Right. Okay, yeah. Okay. So copy it all into CH root. Image on that image. Okay. So we create it, we mount it. Okay, and then we unmount it. Okay. All right, I think that works for me. Okay, and then we don't want this 9p stuff anymore. Actually, this command has drive on it. It's a drive here. There's a better way to do this, I think. Okay, just okay. Let's give it a go, eh? Copy it into the image. Okay, so could not open kernel file. Okay, yeah, so let's go ahead and put that somewhere else too. So could not open kernel file. So copy kernel to host for when image is not mounted on start. Okay, so we'll just say cp bz image to let's see, bz image host. We'll just call it, right? So ch root vm disk vm bz, or let's see, bz. So, okay. Okay. Let's try that. Okay. Let's blow up the disk real quick. Okay, now we can do BZ image post. Motherfucker, okay. Virtual machine. Oh. On host file system used passed to menu. Start. All right, let's see. Okay. Oh, that's right. So okay, so we're gonna boot to Pixie. All right, so we're giving it a hard drive. We're booting to Pixie. We're in EFI mode. All right, and then we're just gonna okay, so yeah, okay, no, yeah, well, that's what we do. Okay, so kernel should be this. Let's see. So we don't even need that. This copy. We don't even care what the BZ image is. Okay. It's coming up. Okay. Okay. Boot options. All right, so now console equals TTYS0, right? So, because or else we're going to lose our shell here. Let's see. Maybe I was just impatient before. Okay, so obviously we're getting some output here. Booting Arch, this is Arch Linux. Alright, so. Alright, okay, great. So. Okay, great, we're on the network. Wow, okay, they've gotten colorful here, huh? So. Let's see what we got. Okay, so there's SATA. Alright, okay, so great. So. Okay, so we should have mount dev SATA. What does this script say? Linux root partition is P3. Okay, so 3 mount root or EFI partition. Okay, so how do we find out where the EFI partition is supposed to be? Boot. Where do you mount the EFI partition? EFI? Okay, so what about maybe if we went to the installation guide, partition to disk, example layouts, okay, mount boot, dev, EFI system partition, okay. EFI with GPT, mount / boot. Okay, so, and then what does this format be? Okay, then this formats the swap space, so P2 is swap, so swap on dev SATA 2. Okay, now we'll do arch chroot mount. Proc does not exist. Okay, ls-laf mount. Okay. Okay. Proc. Let's try that. There's usually another one too. Is it dev? Does dev exist? Dev. Let's try that. Okay, it doesn't like that. Segfault. All right. Okay. So we're running a 5.19 kernel LSP PIE executable. Why did you segfault? Maybe it's just a fluke. Usually never is. Okay. So maybe there's just no bash in there. We need like an environment. Okay. Okay. Okay, so okay. Okay. Let's try CH reading in now. With bash. No. Okay, so using okay. Okay, so okay. What the fuck is going on? Why is bash not in the container? Okay, so we have a mismatch probably between the VDSO. So the VDSO is something that sits in memory. Transport. Okay, so this is a slightly different path. Export path equals. Okay, so this is the one that works. Okay, there's APK. No, that's right. Let's see. Tools. Okay, we can install things. That's good. Yeah, it's the VDSO. It's definitely the VDSO. Okay. So, what I feel like I saw. Why would it be segfaulting? Okay, so we just add ZSH. Okay. Weird. Okay, I'll just copy this one more time because I'm not sure where we're at with this. Okay. Okay, I'm guessing there's this environment variable. There's a discrepancy between the environment variable somewhere. Okay, so same container pod ran. Self-serve file. Okay. Oh. I think I see what it is. No. We have a home. Okay, I don't know. Closer. I don't get it. Okay. Okay, so there we go. So we did arch-c8 root. Okay, but then we still have this issue with the path. So okay. Okay, there we go. So now we have a working PS. Okay, so let's see. Okay, so what we would need to do now is say so vi etc password. Okay, so ash. Okay, so root function is ash. Okay. So okay, so we put the stuff on the disk, right? So now what we need to figure out is how do we Okay, so okay, search LSB, okay. Okay, so yeah, so we don't have any of those installation of utilities type things. So yeah, we don't have any of those things. So huh. All right, you know, let's just try to do one last thing here. Bootloader. Control. Okay. So it looks like these are not non-volatile variables. So I think these are EFI. This is like EFI stuff. So it's exposing stuff to us. So loop control. Okay. Okay. So yeah, we need one of these that's still in the other Fedora world. Okay, so DNF. Search. Boot control. No match is found. To install systemd UEFI boot. Make sure that the system is pretty and UEFI variables are accessible. Okay, so yeah, so this basically should be exposing them through here. Yes, okay, so this should be the same sort of situation. So UEFI boot list. I don't think we have that yet. So without ESP will be used to denote ESP mount point. This assumes you have CH rooted to your system's mount point. Okay, so okay. Okay. So I'm actually going to jump out of here and see ESP path. So boot path, mount boot, ESP path, UEFI, not the ESP. That is the wrong type for extended bootloader partition. Separate boot partition can be created to keep the kernel and init manifest separate from the ESP. don't think we care about that. Boot path. Extended bootloader partition. Okay, so I don't think we care about that right now. And okay, but then I think it might have picked up the wrong, yeah, copy and user. System D. Okay. Find that. We want to make sure it grabs the kernel from the, actually, okay, it doesn't even have the kernel in there. Okay, so let's just try this now. I guess we can just try booting to the image now. Okay. Okay, so I use, okay, and then what was the curl command to download those? It was download page, Pixie images. Where's the Pixie images? How did we get to that page? Netboot. Okay, so alright, so if there's no Pixie files, we download. Only add dash kernel for first install. Okay, and then just external command line. So this got significantly more complicated as far as the script goes, actually. Okay. Installation. VM. Alright, so we're using DigitalHost and Fedora. Host. Okay, so first boot to boot and install via Arch PXE, then reboot without PXE media attached. PXE kernel to boot the system. Install bootloader. Okay, where was that bootloader stuff? Okay, yep, there we go. So mount partitions. Mount dev SATA 1 at boot and SATA 3 at mount, and then swap on to. Okay, great. Okay, and I don't think we changed the Docker files. Okay, system D network D. Okay. Okay, so this should start us up. So how will it know though? Reboot into firmware interface. What did it say before that? Failed to boot from PCI root. Not found. Alright, so loading UI app. Okay. EFI internal shell. Okay. Actually, from UEFI. Okay, this boot control. Boot control status. System deboot. Loader. Okay, bootloader interface. Okay. Bootloader entries. New kernel's installed. Okay, you create this entries.conf. Okay. Okay. To bootloader specification. Okay, so okay, Linux and initRD. To unified kernel images. Okay, draw cut. Okay, I remember we ran into this earlier, so draw cut, unify. Okay. Okay, I think if we can generate the EFI stub here with drawcut, then we'd be able to boot into it. But at this point now, I'm kind of just like, I think that there's a lot of things that Wolfie doesn't provide that might be kind of annoying for running on a real system, like the lack of LSBOK and such. So I'm not sure how much time I want to invest into this right now. So we might go back to, I think it would be nice if we could figure out how to automate the creation of this VM image. Just to use this to do the compressor generated XC UEFI. Instead of creating a RAM FS, the default output is okay. Do we have this? Okay. Let's try to download this. So this is, remember, the container on the top here is Fedora. At this point, I just am curious if this will work. I don't think it's going to be my daily driver anytime soon. But, you know, it's interesting. Okay, UEFI. Cannot find kernel module directory. Oh. Okay, so kernel version. This should be the container that has this stuff in the image not known. Okay. 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 So draw cut. What else did we have that we wanted on here? Okay. System D, network D. Search. Okay. I'm losing patience. Oh man, I'm really losing patience for this. Come on. Kernel version. Okay, so this says go. I'm not trying that. Okay, so we should be able to do that. Okay, so basically we should be able to just say kernel version. Can we point directly at a kernel? Okay, so do we have to rock it in here? This is the problem when you start throwing two distros together. There's no real path. Area by Hello.
You get out of these you and all your beverages.
Yes.
You buy them.